Hi, my name is Jamie Bray. I'm a forensic scientist at the Montana State Crime Lab in Missoula, Montana, and I'm here in Billings to present CSI Fact versus Fiction.
And at this time, it's my pleasure to introduce to you Jamie Bray. Jamie is a native of Billings, Montana, and she's a graduate of senior high school in the University of Montana. She now serves as a forensic scientist at the Montana State Crime Lab, and tonight she has a very special presentation for you called CSI Montana. So if you'd all join me in welcoming Jamie Bray.
Thank you. Good evening. I apologize. I'm suffering from a little bit of a cold, so my voice is a little muffled. But I want to thank the Billings Clinic Foundation for inviting me over to present to you CSI Montana Fact versus Fiction. I'm a forensic scientist at the State Crime Lab in the field of DNA serology. I really like my job, and I'm really excited to tell you a little bit about what I do. The background picture is probably the goriest thing I'll show to you tonight. I promise I won't be showing bodies or anything like that. But this is a picture of a good example of blood pattern analysis, which is a subdivision of forensic science. So, how many of you have seen CSI? I won't judge, I promise. Okay, it's out there. There's a ton of shows out there now. There's the original one, CSI Cyber, I think is the new one. My personal favorite was CSI Miami with Horatio and his sweet aviators. And so CSI came out, I believe, in fall 2001. And it kind of painted forensics in a different light. It combined the crime scene investigator and the forensic scientist into one. And so tonight I'd like to kind of debunk that myth and show you what it's like to be a CSI versus what I do, a forensic scientist. So what is a CSI? CSI is a crime scene investigator. In Montana, the crime scene investigators are police officers and sheriff's deputies. I know in some of the larger towns like Billings, Missoula, they have crime scene investigators, but it's made up of sheriff's deputies and police officers. Their primary duty is to collect evidence, document the crime scene, and deliver the evidence to the crime lab, which the majority of the evidence is delivered via mail to the crime lab, which is in Missoula, Montana. A forensic scientist analyzes that evidence that's brought in from law enforcement agencies, and we have specialized fields. So what I can't go across the hallway at my job and go do firearms analysis. I am only a DNA analyst and can only do DNA. I do have to have some basic knowledge of what the other sections do, just so my analysis doesn't affect, say, what latent prints does. I don't want to swab an area of a gun if there's a potential latent print there. So I have to have a basic knowledge of what other people do. So CSI versus the forensic scientist. On the left, I think this was taken from CSI Miami, and this is a picture of their DNA lab. On the right is my two colleagues, which I took a couple days ago, doing the first step in DNA analysis, which is the extraction. So you can tell there's multiple people talking over evidence. They're not wearing masks. It's really darkly lit. They're somewhat attractive. The people on the right, I would say, are attractive people too, but they keep their mouths covered with a mask, not to spit or talk over the evidence. They're working in hoods, they're gloved, it's a controlled environment. And so if you saw this on TV and saw what actually it is in real life, it's very different. So anyone can be a forensic scientist, except you probably should be human and above the age of 2.5. So that's my dog, Radar, and my daughter, Ada. Surprisingly enough, Radar was much more into getting dressed up than Ada was. But they both enjoyed it. So what does it take to be a forensic scientist? You need a 4-year degree in what we considered a hard science, so molecular biology, chemistry, biochemistry. There are some programs out there that are forensic science-based, but we really recommend a hard science, so biochemistry, chemistry, degrees like that. A strong stomach. You see and really smell some not so great stuff. And so having a strong stomach to deal with that on a day-to-day basis helps. A good sense of humor also helps. You deal with some pretty nasty stuff, you deal with some horrible things, and trying to keep it light and having an outlet helps. You can't have any felonies. If you testify in court with a felony against someone charged with a felony, it kind of discredits you a little bit. A good understanding of the justice system. I testify on average about 5 to 6 times a year, and knowing and dealing with attorneys, both defense and prosecutors, it helps to have an understanding of how things proceed through the justice system. Also good public and writing skills. So what do we do? What do I do on a day-to-day basis? I'm constantly learning. The science is definitely, and DNA is always changing. It's getting more sensitive, so we have to stay on top of things like that. I'm in pre-trial meetings for current cases, meeting with defense and prosecutors over a particular case that might be going to court. I'm actually out in the lab from time to time doing analysis on actual items of evidence. I teach. I provide teaching to law enforcement agencies as well as prosecutors, defense attorneys, students on what I do. I give testimony. I'm on the phone quite a bit, communicating with law enforcement agencies and attorneys. I have to, in my field, I have to take 8 hours of continuing education a year to stay proficient in my field. And the technology is consistently changing. Back in the day of early DNA analysis, for example, it took probably something like that, about the size of that, to get a DNA profile. And today, I can get a profile from a pin drop of blood. So the technology is really changing. So we're not investigators, we're not a jury, we're not a judge, and I'm not a cop. I'm an unbiased person, and so the evidence is delivered to the laboratory, and it's my job to look at the evidence and answer the questions that are presented before me. So let's talk about the crime lab. I'm going to take you through kind of a fictional versus the reality, I guess, of what it is to work in a crime lab. So CSI versus the Montana State Crime Lab. These actually look kind of like 2 futuristic crime labs, but they're not. The one on the left is the FBI lab in Quantico, Virginia. It's recently built and it's pretty darn state-of-the-art. They house, I think, over 200 scientists there. A lot of the evidence, federal evidence, goes there and gets analyzed. The one on the right is the Miami-Dade Crime Lab that is featured in CSI Miami. This is our crime lab. Just kind of a womp-womp. But we're housed in Missoula, Montana. It's about 10 years, about 15 years old. We had the building built in the early 2000s. There are 33 scientists, or 33 people that work at the crime lab, and 24 scientist technicians make up that 33. The other individuals are the medical examiners, the administrators and administrative assistants, and the evidence technicians. So we're located in Missoula. We're the only crime lab in the state, so all the evidence that is collected from all the major towns, all the major counties, from all 56 counties is sent to us. So, what are some of the services that we offer at the State Crime Lab? Well, I'll refer quite a bit to serology and DNA since that's my background, but we do offer serology DNA, trace evidence, which is analyzing hairs and fibers, and that's been kind of weeded out over the years with the advancement of the DNA technology. Latent fingerprints and impression evidence, firearms, chemistry, toxicology, and the medical examiner. We also have breath alcohol there, which helps calibrate the intoxilizers for when you're pulled over for a DUI. But I'm not going to quite go into that tonight. So I'm going to go through each of these sections and kind of do what it's the fictional CSI version of it versus the reality of it. And take when I play the videos of CSI, kind of take a look and compare how it's portrayed on TV versus how it's portrayed in real life. So we're going to start off with, if I can get this to work, there we go, the medical examiner's office. So I had to cut it there because they were going to an autopsy. This is ours. And there's no music. Unfortunately, there's no music that plays. Sometimes it plays when we're analyzing evidence. One time I did have the CSI theme song play while I was analyzing a piece of evidence, and I had to stop and think of the irony. I was like, who is this? Who does this belong to? But our medical examiner's office, there are 2 medical examiners for the state of Montana, and this is where they perform autopsies. So if someone passes away, an unintended death or a homicide, it comes here, and the body provides, well, they want to know what happened to this individual. Why did this individual pass away? So over in the room, kind of to the right, is an x-ray room where they can take a look at the bodies and x-ray them to see if they have any surgical implants, any rods, surgical rods, any knife nicks if someone was stabbed, where the bullet might be if someone was shot. I'm sure you can notice it's really bright in there. There's some good light. The sinks are for washing down fluids. When the autopsy is done, they document the body, and kind of on the crime scene shows, the body's always covered with sheets, and that's not the way it is here. A couple times I've had to walk in and ask the medical examiner a question, and I walk in on him doing an autopsy, just right there, with the body open, and so it's a lot different than what's portrayed on TV. This is our morgue. It's kept in a nice temperature, cool environment. Each of those contain a body, or have the ability to contain a body. They're able to be locked to preserve the chain of custody, and also to respect the dead. So not everyone can walk in and just view the body. It's in a controlled environment. So this is the toxicology section. So a lot of times, if someone has passed away, the medical examiner will collect blood or urine and send it to the toxicology section to determine what that person may have ingested and what might be in their blood. And so the toxicology section has a ton of machines, or what we say in the field, instruments. And so their primary duty is to look for drugs or alcohol in your biological fluids, in blood or urine. And they want to know how much how much alcohol is in your urine, or what type of drugs did you ingest today. So if I had my blood drawn right now, it would show I took some heavy-duty cold medication, and some ibuprofen. So it would show from the time how much or give an estimate of how much was in my blood. And so just to give you an example of kind of what CSI got it wrong. I'm not sure where my mouse went. There it is. I'm going to play you a clip, and these 3 CSIs are anxiously awaiting some DNA results. But you can tell, and I'll go ahead and, where did it go? There we go. The machine that they're waiting for the results from are what's used for toxicology and chemistry.
DNA on the toilet flusher.
On the 310, we're 5 seconds out. 3, 2, 1. Sorry.
I'm just as shocked too. Because that's not what happened. names. Okay, let's go to the latent print and impression evidence section. Oops. I need to go back. Oh, sorry. I'll get it.
Hey,
Hey, the prints on the remote were all Dale Durney, that dead manager. FYI, the batteries are dead. And the prints on the Money's rubber band are Dale Durney and Harry Steadwell.
well, we know Dale pocketed it. Harry probably stashed it.
And why would he leave it there for a week?
We'll never know. And so you can kind of tell from the video that she wasn't wearing gloves, depositing her prints onto, I think it was a remote for the garage. And then their super glue chamber was pretty small. And magically, the picture of the individual popped up. And that's just not how it is in real life or real forensic science. This is our latent prints impression evidence section. This is one area. There's a ton of space, and we need that space to look at large pieces of evidence, like these tires. They look at guns, they look at beer bottles, they look at money, and the large box right over there is the super glue chamber to handle that. And super glue, once you put it on an item, can adhere that latent print to that item so that the latent print analyst can go ahead and do a comparison of the two. So, fingerprint identification. Here are your three basic fingerprint patterns. You guys can all look at your fingers and see there's an arch, a loop, and a whorl. And I have a whorl on one and a loop. And so these are what the latent print analyst uses to compare two evidence. All right, so this is an unknown fingerprint that's found on a piece of evidence, and it's been treated. And so if you've been a suspect or maybe just a subject, like, hey, I might have handled that item, they'll go ahead and get your fingerprints and put it on a known card and then compare it to the known fingerprint. They also do footwear impressions. So say there was a burglary at a home and someone left a footwear impression. They can go ahead and photograph it if they have a good suspect. They can go to that individual's home and, oh, hey, that shoe kind of looks a little similar to that. I'm going to go ahead and collect it so the latent print analyst can do a comparison. All right, let's move on to the chemistry section. So similar instrumentation like the toxicology section, but it's a little bit different. What they're after is, what is that substance? What is that leafy substance that was sent into the laboratory, or that fine white powder? They're looking at what are the illegal drugs, so methamphetamine, marijuana, and they're also dealing with meth labs and the components that make up a meth lab. They also, another component is gunshot residue. They use, if someone's been in a gunshot environment, or where a gun has been, where a gun has gone off, they can go ahead and stamp their hand, which is what they're doing on the right, to pick up some of the particles and view it underneath the scanning electron microscope to look for the elements lead, barium, or antimony to see if someone may or may not have been in a gunshot environment. And so CSI actually kind of got it right on this one, but it shows a good, what is going on? There we go.
The ring? The ring. The ring was positive for GSR.
That means Lois could be the shooter.
I guess we'll have to bring.
We're going to bring her in. And so what the sheriff's deputy or cop would do would stamp that individual's ring to try to pick up those particles to see if she was in a gunshot environment. Our next section in the lab is the firearms and tool marks section. This guy's a trick of all trades. He does everything. The crime has been solved. I don't mean to be sarcastic, but it is kind of funny to watch it if that's what you do. So this is our firearms and tool marks section. This is what I like to refer to as the Wall of Fame. All of these weapons or guns have been collected off of individuals from cases that we've worked in the state of Montana. My favorite, and I don't think it's on here, is someone tried to make a silencer out of a Vidal Sassoon shampoo bottle. So A+ for creativity, but it didn't work. And so it's a wide-ranging variety of weapons that have been confiscated during crimes. Going back to the humor, there's actually a caulking gun up there that really wasn't in there, but someone added it to the Wall of Fame. We do have over 1,000 guns as a reference library that the firearms analysts can go ahead and use as comparisons. So this is our firearms section. There's the main firearms lab, and that would be one of our scientists, Travis Spinder, working on evidence. And you can see through the window, those are actually some of the scientists' cars, so there's no Hummers or anything like that. I think one of them is driving a Tahoe. I showed this presentation to my supervisor, and he's like, you should take a picture of our cars, our state cars. And we don't drive the Hummers. We drive an old state trooper car to court and back, so it's a lot different that way. And so there's the ballistics water tank, which was showed in the video where the guy shot the bullet into the water. That's what's there. And there's also the shooting range. So there's a shooting range within the lab that the scientists can use to fire the weapons, fire the guns. So it showed on the video a little bit of doing the comparison. And so they use a comparison microscope, and they're comparing the cartridge casings and then also the riflings from the gun or the tool marks. And then with the range, they're able to determine how far someone may or may not have been shot and give an estimation. They also do some serial number restoration as well if someone has tried to destroy the serial number off of a firearm. So this is my bread and butter, DNA serology. Over there is Watson and Crick, and the molecule, the DNA helix. And let's see if I can find my mouse again. Let's see here, where did it go? There we go. So I think we're going to take you to Miami. If this will work. Oh, no. Oh, there we go. Right there. Going to Miami to visit their DNA lab. She was doing DNA on corn, and we don't do DNA on corn. We can only do human identification, and that's another kind of misleading fact. But I'll take you through a tour of the DNA serology section. So this is the main serology lab. It gives us a large amount of area to look at different types of evidence. I've looked at anywhere from clothing to car parts to actual cars. We have a garage at the lab where I can go out and examine cars. I've looked at, what else have I looked at? Just lots, bedding. So it gives us an ability to lay evidence out, to look at it. This is the DNA extraction room. And so according to the FBI standards, we have to analyze evidence in different sections of our, different rooms in our section, and that's to prevent cross-contamination. So in the DNA extraction room is where we're removing the DNA from the substrate. So from, say, blood on genes, and then we're adding chemicals to it to release the DNA from the nucleus of the cell. In the PCR setup room, we're adding reagents to that DNA, and then we're placing that in a thermocycler to amplify it and get billions of copies of DNA. And then on those kind of globe little things, those are the capillary electrophoresis machines, and that will develop our profile from our DNA. So that's kind of a little bit of DNA in a nutshell. But let's talk about what is serology versus DNA. Serology is the identification of biological fluids. So on the left, right there, is a stain that is illuminating under an alternate light source. And sweat, for example, could illuminate. The forensic scientist will go ahead and circle that and then do presumptive testing on that and see if it is maybe blood, and then if it is, send it forward to DNA. DNA is the genetic storage device found in the nucleus of our cells. It's identical in all of our cells, so if I swabbed my right cheek and swabbed my left cheek, it would be the same DNA. And it's the blueprint for an individual. And it answers the question, who does the fluid belong to? Serology answers the question, what is the fluid? So where might DNA be found? So we're looking for blood, biological fluids from sex assaults, sweat. We're looking for those type of fluids on items of evidence, such as weapons, clothing, mouth contact items. So we can swab a soda can and see if someone's DNA is on that. Or this is a picture from a crime scene. We're looking for blood on that shoe. We'll go ahead and swab it and send that swab forward for DNA analysis to see who does that blood belong to. So a typical day in my life is the crime scene evidence is gathered by the police or the sheriff's deputies. It's sent forward for examination, and then it's first looked at by the serologist to gather the staining any of the biological fluids. That stain is then sent to the DNA analyst, who's going to extract the DNA, amplify the DNA, and generate a profile. And from that profile on the evidence, we can compare it to a known profile. So any individual that might have been involved in a crime, they'll submit their buccal swabs. So a swab from the inside of your mouth will run their profile and compare the two. And then, if it's an unsolved crime, and there's no suspects, we can upload it into CODIS, the Combined DNA Index System, where that unknown profile is searched all over the US against convicted offenders, other unknown profiles, to see if there's a match that way. Okay, so this is how CSI gets DNA in 60 seconds.
Are those the samples for the DNA, Bill?
Yeah, they're almost ready for the 310.
I've got one more sample for you.
You worked in here, Natalia. You know the evidence submissions are processed in order, so you can wait for the next run.
Valera, one of those pictures is of my sister. That reads the joke. Please compare this against these other samples.
I'm sorry,
Just do it now, okay?
mister. What's going on?
Girl in the toll booth car. It's my sister.
So it just doesn't happen like that. I wish it would. But in reality, so it's hard to see, I know, but this is a process map of the DNA analysis at the State Crime Lab. And we did this project, was map out all the different steps, all the decision making that it takes to work one sample. And so to give you an idea, this map extends from probably me all the way over there. And all those circles, which are hard to see, are steps or decision-making process to work one sample. So the biggest frustration we get is, why does it take so long to get DNA results? And it's because we have to adhere by strict standards that are set forth by the FBI, and we have to meet those standards. We can't just do DNA on corn. We have to make sure and put the new chemistries through exhaustive test before it ever reaches a piece of evidence, because a lot of times that evidence is, we only get one shot at trying to develop a profile from. And so in 60 seconds, it would take me 60 seconds just to walk the length of this. Just to give you an idea, what she was doing in that video clip was extraction, amplification, and then running it on the capillary electrophoresis to generate the profile. Just part of the amplification takes 2.5 hours, and to run it on the CE takes one hour, and extracting takes an additional 1.5 hours. It doesn't make good TV if you sit there and watch a scientist for 3.5 hours painstakingly pipette, but it gives you an idea of, if you're a jury member and you're only on a jury and the only exposure you've ever had is to CSI, you're probably wondering, why is it taking this girl so long to develop a profile? But this is why. And this is what a profile looks like. We're looking at 16 regions on a chromosome. They don't code for anything. It's kind of considered junk DNA. You get half from your mom and half from your dad. The only thing that we can tell is the sex, if you're male or female. But this is what we use to compare evidence to known profiles. And then we apply statistics. So yes, there's a little bit of math involved in DNA and in forensic science. I ran my profile and I came up with this statistic. So if I were to commit a crime, my statistic would be, if I had a random population, what are the chances of seeing my profile again? And it turns out to be 1 in 247 trillion, 400 billion Caucasians, which equates to, so there are 7.3 billion people in the earth. It would take 33,890 Earths to equal that many people before we'd see my profile again. So it's a pretty effective tool to show juries about how rare something might be. I talked a little bit about CODIS. So if we have an unknown profile, we can upload it into the Combined DNA Index System, which is run by the FBI. There's a state database and then a national database, and they search one another. If you've convicted a felony in the state of Montana, you're also required to submit DNA, and we run it to be searched against all profiles in the United States and Puerto Rico. And so it provides matches between unsolved crimes and offenders, or other unsolved crimes reported to law enforcement agencies, and it also gives an investigative lead. And Montana has over 200 CODIS hits so far. So one of the big ones we talk about was a woman that was killed in Arkansas. They developed a profile, they submitted it to CODIS. There was an individual, I believe he was in Hamilton, Montana, committed a homicide. Homicide is a felony. He submitted his DNA. It was uploaded into CODIS. It hit to an unsolved crime, and that unsolved crime of that woman in Arkansas. So it's a really good investigative tool. So what does a CODIS match look like? Super exciting. These are our regions of the DNA profile that we're looking at. So the loci, or the location on the chromosome, those are our the locus that we're looking at. So the candidate we don't see a face. It's given an unknown number, just this random number. But that's the candidate or the offender's profile. And then it hit to the forensic unknown, which is on that middle. So you can see the numbers match up at D8 at the top, a 1314. So did that offender, a 1314. So what a CODIS match doesn't look like. This is what normally is seen on CSI. So you're gonna just upload the whole profile. It's gonna search. It looks just like that. And it's gonna come back to a match, and you're gonna see a face, you're gonna see a name. That's not what it's like. We have to, all we have is a number, and it's kind of funny because that's our CODIS administrator. She runs the whole program, and that was her profile before, so she did that for me. But we have to have a little bit of just the unknown. We can't have a face, we can't have dates or anything like that. If it does match, we have to do a hit confirmation. So if we have an investigative lead, that individual will have to resubmit their DNA. We run it to make sure it's the same individual, and then we submit that information to law enforcement, and then law enforcement can release the information. All right, that's it, guys. Has anyone seen, so the last bit, has anyone seen the Lego movie? Okay, so I was searching on the YouTube. Let's see if I can get this to work. There we go. And this teacher came up with the Science is Awesome one, which I thought was fun.
Heard the news? Everyone's talking. Life's good because science is awesome. First day of school is a new opportunity. Time to be part of the Salem community. Science for awesome and awesome possum. Learn all about problem solving. All year long, by experimenting, studying fossils. Science is awesome. Step in the lab, gotta wear proper shoes. Awesome to try, not cool to snooze. Not cool to snooze. Not cool to snooze. Not cool to snooze.
Science is much better when we came together. Side by side, you and I will have a learning adventure. Let's research together. We're the same, I'm like you, you're like me. We're all made out of energy. Science is awesome. Science is cool and we're part of a team. Science is awesome. Though this isn't a dream.
All right, try to get that out of your head for tonight. Does anyone have any questions they want to ask? Any questions? Okay, thanks guys.
And on behalf of Billings Clinic and our community, we'd like to present this plaque to Jamie for coming to our community and sharing her knowledge of CSI Montana with us. So thank you so much.